Okay, today I'm going to present you an architecture, and this architecture is coming from a real use case I am working on. And this architecture is strict ordering messaging from on-premise business application to OCI Oracle application. So as you can see, the customer has a specific business application, and you need to send message and then information in an Oracle application that is on Oracle Cloud infrastructure. The problem is you cannot send information directly from the specific business application to Oracle application because the customer wants to be able to stop Oracle application in order to patch the application for maintenance. Okay? As you can see, you can put between the specific business application and Oracle application on OCI what we call a middle layer. Okay. So at the end, we will use Kafka. We will send messages from specific business application to an OCI Kafka managed service, okay, OCI streaming. Then this middle layer will consume messages and call the SOAP services in order to send information to the Oracle application. First, you can note that we put a component, API gateway, in order to protect Oracle application. Sure, this architecture with Oracle application has a limit. It means you should not go over the limit if you don't want to crash this architecture with Oracle application. So you can protect this Oracle application putting a rate limit here on the API gateway. So that's nice. What are the constraints? First, strict ordering messages. It's very important that here messages are ordered. It's very important to call SOAP service, keeping the order. Another constraint, no lost message, no duplicated message. You should not call and send the information twice. Another constraint, Oracle application can be stopped for maintenance. So this component can be stopped. Another constraint, the middle layer can be stopped for maintenance. Okay? So as you see, with all these constraints, you can imagine that consequences on the architecture are quite strong. Okay? A point of attention, okay? Because here we will use Kafka. Kafka is very nice in order to send and to produce and consume messages with a strict order, so it's okay. But we have a point of attention, and the point of attention is the average rate of the messages should not be overall higher than the average rate of the SOAP service. Sure, if you send too many messages and you cannot consume them, then you will have a super big backlog and you will never be able to consume this backlog. So sure, at a time t, you can be higher with messages than the rate limiting. It's not a problem, but not if you consider the average rate during a day, for example. So you can have a lot of messages at a time t, it's not a problem. Then you will have a specific message from the API gateway, too many requests. And the goal of the middle layer is just to retry again to send information to Oracle application. Okay? Now, I have done a small code to check this architecture, mini POC. Okay? I use here a REST service with Spring Boot, okay, just to simulate it exactly the same than SOAP services. And I use OCI streaming. I produce message orders from a customer in a Kafka topic that has 3 partitions. And as I use as a key the name of the customer here, then all the messages can go to only one partition and I can have a strict order. Here I received the messages in the strict order and I call here the REST API in order to send information. I will show you a demo with that and I will stop Oracle application for maintenance. So the REST service for maintenance, I will stop the middle layer, okay, here, just to see what happens. And we will check that all the messages are in the good order, okay. So let's go now. Consumer, okay, are here. First on the cloud, I have my topic. My topic is topic 2 for the demo. I have 3 partitions. It means I can start 3 consumers. Each consumer will connect to one partition and get the message in order, okay. I have the gateway in front of my REST API that is running on the cloud here in a VM, okay. And I protected this REST API with a rate limit, okay. For the demo here, so for the demo here, just to have a look to that deployment, okay. I choose to a rate limit at 1 message per second. It's very small, but I want that you are able to have a look to the order on the message, okay, on my screen. 1, 2, 3. So if I send too many messages, you will see nothing. That's why I choose a small rate just for the demo. Okay, so I start the consumer 1, okay, consumer 2, consumer 3, okay, so 1 consumer per partition, okay. Then I will send message. I have a property file. Each I send message, 1 message every 2 seconds at start, and you know I have a rate limit at 1 message per second, so it's okay with this rate. Okay, just to check that it runs well. Okay, so the producer. Okay, let's go. 1 message per second. Okay, just have a look here. Okay, the 3 first messages are from a previous test, so forget them. So this test is starting with message 0, 1, 2, 3, and so on. Okay, well, as you see, the order is good. Okay, just to have a look here, you can see that the success API call is 100%. Okay, so everything is okay, no error. Now I'm going to kill the Oracle application. Oh, Oracle application is not here. Okay, so you see waiting because the middle layer detects that there is no more Oracle application. I restart it. As you can see, I stop here 25. When I restart 26, I always add the good order. What you can see too is or here, okay, what you can see here's too many requests. Why? Because the middle layer was stopped, but the business application of the customer sent messages, and these messages are not consumed. Okay, I restart then Oracle application. This is my mock with a REST service, and so the middle layer have a lot of message to proceed. Okay, and so send, I have a lot of message, but the API get away, say, hey, oh no, too many messages, keep cool. And so the middle layer have to retry again and again to send messages, but at the end it is okay. Okay, and the order is good. Now I'm going to increase here the number, okay, of messages that I send. So I send one message per 500 milliseconds, or you know I have a rate limit of 1 second. Okay, and then so I will go over the rate limit. Okay, it's like a peak, you know. It means the business application send a lot of messages, but Oracle application is not able to take all the messages. Okay, let's go. We'll see here, more fast, always the order. But looking here, we see that the percentage of too many requests is increasing. Okay, and before we have a percentage for application off due to the stop of the Oracle application. Okay, now I stop this peak. Okay, just put a message every 3 seconds. Okay, now every 3 seconds, and what you see is, okay, it's always good. Now, okay, and I lost no messages. Everything is okay. The only thing that I can see is, okay, now the percentage of too many requests will decrease. Okay, because I receive message, I consume, I send, okay, nice status, okay, and everything is okay. If I let this architecture running like that, then the percentage of too many requests will go near 0, and the percentage of success call API, okay, will go to near 100%. Okay, the last test here is, okay, I stop the consumer. Okay, so want to stop all the consumer. This consumer stop, this consumer stop, this consumer stop. Okay, so I stop the consumer. So the middle layer is out, no message. Okay, and now I start again the middle layer. Okay, and so what happens is business application sending message, but the middle layer is not here. Okay, so middle layer will start again, will read message at the good offset. It means start to read the good message and to keep the good order, and we will have the message that are coming. Sure, during this short period of time you have so many messages that was not proceeded, that sure you go over the rate limit and you have some too many requests, a lot here, because during this short period we are over, and API gateway say no, you cannot send so many information to the Oracle application, please wait, try again. And the middle layer, try again, and try again, and try again. And now the middle layer, it's okay, we have one message every 3 seconds, okay? And each time, every messages are in the good order. So this mini POC is super nice to prove how this architecture runs. The next step, sure, is to do a real benchmark with real product, real business application, and OCI. And I'm sure that it will run very well, but we need to double check that in the future. Thank you for your attention.